So, look. So, right here.
Fair warning.
Hey guys, go ahead and get your formula sheets out. Get your formula sheets out, okay? Make sure you have those formula sheets in easy reach, because those will be very helpful as we work today. In just a minute, I'm going to get us started. Yes, Lexi.
Okay, thanks.
For number 5, it's going to be like a part of the page.
What it is, like, the difference between yeah, but like, you don't mean college, it's like, I heard that, like,
Let me read it more So do 4, 5, and 6. We're going to start in about 90 seconds.
whoa, I need like,
Maybe a little bit longer, because I think number 6 takes longer. I think number 6 takes longer. Unless I'm misremembering. It's on the sheet I just passed. Oh. No. I see. Oh, I was going to get it. Fold's Campbell. So, no, I was just going to get this Campbell. Make scan or copies of that.
you want just copies of this?
No, both of those together. Yeah, we'll just do that as the test for third block.
But it's only knowledge driven, so we can't really calculate it. Because you could just have one person have it.
Huh?
Maybe probably these. Wherever those are. I found them.
Compare location A to month. For location B, I don't know if we need. Let's look at that. I currently agree with Steve. We just have location A to month, that one's not true. Compare with location A, and the median. So we either have the median is greater or the median is not.
Well, not the content on that, but like the stuff we did in class.
I could agree with that, yeah. Sorry, I just need to make sure that these are there. I don't. Yeah, just more making sex repetitive process and orders approximately normal. If you pass one, you're probably going to panic.
I forgot how you used to calculate it.
No bearing,
I think there's
what's the passing on the calculator?
Okay, so it's been 4 minutes. We got to get those done. We need to start going over them. We're gonna. I think 6 may be the one slowing us down, but we got to move more quickly, right? How much time do you have per multiple choice? 2 2.25 roughly, right? So I gave you a little bit less than 2 1/4 just because it's a focused 3-minute thing. But let's look at those. After that, we're going to do progress check analysis to help you get better prepared for your test tomorrow. Nope, that's not what I meant to do. AP for response questions, and then start the next unit. Huh?
We agreed on this yesterday.
Could I take it for?
Oh yeah, you weren't in here when we talked about it? Yes. You can. Because I know you're going to, instead of taking it today, we decided to give a little bit more time to study and review.
Well then, should I take it Monday then?
That's your choice.
Okay, Monday.
Okay. Number 4, a car rental agency has 2 locations in a city. Box plots below summarize the miles driven for 1 day of single-day car rentals each location. So this one, I would just go question by question, right? Or answer by answer looking at them. Is there anything wrong? And I want you to hear me on this language, because I think this is an undervalued tool for students on standardized testing. Is there anything wrong? We look for the right answer, but look for the wrong ones. Is there anything wrong about A?
Yeah, all of it.
What's wrong with it?
You can't show single points on the right box plot.
Right? The number of single day rentals is greater for location A than for location B. Can we see how many there are? No, that's the one issue with box plots. We can't see how many there are. B, the number of single day rentals is less, so well that's the same issue, right? Is there anything wrong with C? Compared to location A, the miles driven for location B display more variability.
No.
Nothing wrong.
What's wrong about that?
Nothing.
Yeah.
Honestly, they are.
Wait, you're saying yes for that one?
Yeah,
Yeah.
that's right.
Oh,
It's right.
sorry. Y'all did not
Yeah,
hear the
no.
question I asked. The question I asked is there anything wrong? And then you go, yeah. And I'm like, what? So,
no.
compared to location A, was the miles driven for B display more variability?
Yes.
Yeah.
Is there more spread there? Yes.
So,
Is the median greater?
Yes.
Yeah.
There's my answer. Now I'm going to check D and E quickly. Compare with location A, the miles driven for location B display less variability.
Wrong.
Wrong, right? Greater IQR, greater range, whole thing. E, compare with location A, the miles driven for location B display, again, less variability. Is the median about the same?
No.
No.
Okay, so use that process elimination, read all your answer choices, and look for the incorrect details, right, Austin? That's what I heard. What up, Deacon?
when it's talking about variability in box plots, is it talking like specifically about the IQR, the range, or the outliers, or just taking all of it?
Yes.
Great.
It's just variability. It's spread, right? So notice though, which one has a greater IQR?
B.
Which one has a greater range?
B.
Okay, right? Don't make it more it's true for both. If it wasn't true for both, they would clarify in the question.
Do you count the outliers as part of it?
Well, yeah. The range is the maximum minus the minimum, right?
Right.
Now, that's also why we don't like to use range, because range is what?
Oh, I forgot the word.
Yeah, we need it. It is what?
Is that a bias estimator?
It's not a, it is a bias estimator, but that's not why we don't like to use range. We don't like to use range because it's
Influenced by extreme values.
It's heavily influenced by extreme values.
Yeah, what's the word for that?
Resistant
There it
to
is.
outliers,
Yeah,
right?
resistant.
So the range is not resistant. The IQR though is resistant, right? 5, at a small coffee shop, the distribution of the number of seconds it takes for a cashier to process an order is approximately normal with a mean of 276 seconds, standard deviation at 38 seconds. Which of the following is closest to the proportion of orders that are processed in less than 240 seconds? Guys, what's the first thing we should do here? Even before z-scores. I'm going to draw that normal curve, right?
On a multiple choice.
On a multiple choice, I know it's wild. Like, we're not used to showing our work for multiple choice, but you always should. And when you see what tells me here to draw a normal curve, approximately normal, right? Boom. So approximately normal. Now, you can do something without the z-score, but that z-score is really useful. And so, how do we find that z-score again? Value
Minus mean.
minus mean. So what is my value? 240? Less minus the mean, which is 276, divided by my standard deviation, which is 38. So what is my z-score?
It should be like negative 9.4, I want to say 3, I can't, yeah.
It's said
7.3.
negative 9 point something?
Negative 0.9.
Oh, 0.9. I was like, 0.9.
473.
Yeah, that's what that is.
Did you just forget that point in there?
Yeah.
Yeah, I was like looking at it, I'm like, there's no way it's a negative 9, but I got you now. All right, so negative 0.9473. Remember, I'm just going to draw my line there. Which direction do I need to shade?
Left.
Left. And then, am I doing this by hand? Heck no. I don't know what that is, but my calculator does. Right? What's my lower bound? Negative a bunch, right? What's my upper bound? And so normal CDF, and what is that probability? Or that proportion? No.
J. 17.
Did you do negative 10,000 up to that?
Good guess.
No, I didn't know.
0 point,
No, that-
no, you did a positive, not a negative.
Oh my.
Be careful with that. Alright, who had their hand up? Bryson, what's up? Yeah.
Okay, I did normal PDF, what's that for? I don't know.
So a PDF is a probability density function. That just gives you the height at this one point. Remember, when it's cumulative, you use CDF, cumulative density function. Do I need to clarify or remind anything about that? Are we good? Joseph's good. Logan? Good. So we're going to do this on the AP exam, right? Not try, we're going to do it. We see that word normal. We're drawing our normal curve. We're doing our z-score. Number 6, this is definitely one of the trickier ones. But again, I know, because Deacon's like, show my work on multiple choice. I know that's not what we're used to doing.
I did show my work on it.
Okay, good. Always show work if you need to. Or if there's a way to show work, because it's going to help you visualize. So on 6, what should we instantly be thinking about? Say it again.
Actually, I didn't even need to do
I would use z-scores. What here tells me z-scores? The number of standard deviations. Literally, what is a number of standard deviations? That is z, right? So 2.42, my z, is equal to my value. What's my value again? 1637. What's my mean? 790. What's my standard deviation?
I don't know it.
Oh, we don't know it. So S, sigma, X, any of those will work. So that's how I would solve this equation. Right? Just solve it. 2.42 times S equals, what's that difference? 847 maybe?
Yeah.
Yeah, I think so. Yeah, 847.
Just use that calculator. Alright, so what is S? 350. Yeah. So use the language to drive what you're thinking about. As soon as I see the number of standard deviations, holy crap, that's a z-score. As soon as I see the word normal and I'm looking for the area under the curve, the proportion, the probability, I'm drawing a normal curve, right? Questions, comments, concerns? Are we starting to feel a little bit better about the AP exam now that we're starting to review some of these things? Yes, you do, Leah. Don't lie to me. / lie to yourself. Alright, so we're going to do progress check analysis. I identified several questions based on what I saw us struggle with. I cannot spend forever on these because we got to do free response today as well. And so I'm going to move quickly, but let me know if I need to clarify anything at any point. Because the progress check analysis. So I'm about to pull up the progress checks. Look at some specific questions. Oh, your formula question. Yeah, good question. All right, so before I get going on this, we do have a question that I want to address, the formula. So first off, I always want to remind you, if you have a formula question, where's the first place you should look?
Formula sheet.
Fight you. Formula sheet, right? If I want to do a Z test, right? If I want to do a test, what formula does it have on the formula sheet for a test? The standardized test statistic is equal to what?
Statistic minus parameter over standard error of statistic.
Divided by standard error or standard deviation, either one. Depends on the context. So remember with this, right? This is also essentially saying Z. There is a t-score that we'll learn next unit, actually today, but it doesn't change much at all. It doesn't change anything. Chill. Stay calm. So, but Z, right? And so when I look at this question, we need to recognize if my null hypothesis is something like p equals 0.7, what would my statistic be? I don't know the value, but what would the statistic, the point estimator be? P hat. What would the parameter be?
0.7.
Well, just p, right? Divided by, and what would my standard error be? Is this somewhere on the formula sheet?
Deviation.
So look at the formula sheet, right? We'd be looking under proportions. We'd be looking under one population.
Would be square root of p hat times 1 minus p hat.
Is that correct?
No, it would be just P. Yeah.
So remember, if you have a hypothesized P, we have a P, we're going to use P instead of P hat. Okay? Because do not forget, everything with inferential statistics is built out of what? Sampling distributions, right? And the standard deviation of p hat is the square root of p times 1 minus p divided by n. So if I have a p, I'm going to use my p. Does that make sense? Good with that? So, in a similar way, if I'm doing a confidence interval, is there a formula on the formula sheet for confidence intervals?
There is.
There is. What is it?
Statistic plus or minus, critical value.
And here's one thing I'll point out for those of y'all who've actually submitted your prayer models. If you haven't, you need to. After the test, I guess, because test is tomorrow. Joseph smiles because he hasn't turned in a prayer model all year. Critical value. I would make sure I take the time to define how to calculate that critical value because that can mess you up. Now, the critical value for 95%, 1.96. It happens all the time. But in case it's something other than 95%, you want to know how to do it. Times, and I think they say standard error. And so if I'm trying to estimate P, what's my statistic? P hat, that's what estimates P. Plus or minus, I'm going to assume 95% right now. And then what would the standard error be? Well, going back to that same formula, notice in this case, I can't use P because I don't have P, which is why I would have to use P hat. Okay? Yes, Aaliyah? Nope, never allowed to have water for the rest of your life. Question number 9. Alright.
It's been like a week and a half since I've actually had water.
Oh my gosh, Aaliyah, that is not healthy. That's like Peyton sleeping 2 hours a night.
Excuse me?
What?
I was minding my own business and you brought me into this. And now I'm getting normal sleep.
I'm so proud of you. Like, all kidding aside, I am proud of you for getting some normal sleep. Alright, number 9 here. Suppose a researcher wants to use a confidence interval to estimate an unknown population proportion P. Which of the following is not a correct statement? Oh, we did this one yesterday, didn't we?
Yeah, we did.
Just kidding. I lied. We already finished this one. Moving on.
No, we just didn't.
Progress check B number 8. Notice how many people have not done their progress checks yet, especially with the test tomorrow. I would probably make sure I do that.
I'm doing it, then don't submit it. Because I'm
Okay.
gonna go back and do the same question again.
But you know I can just, so like you submit it, see which ones you got right or wrong, let me know and I can unsubmit it so you can do it again.
I mean, that makes sense too, I'm just like.
I'm pretty sure I did.
Alright, hypothesis test was conducted to investigate whether the population proportion of students at a certain college who went to the movie theater last weekend is greater than 0.2. A random sample of 100 students at this college resulted in a test statistic of 2.25, assuming all conditions for inference are met, which of the following is closest to the p-value of the test. So, we usually just use the calculator to calculate the p-value, yeah? Okay. But notice they tell us that we have what? A test statistic of 2.25. Test statistic, what is that the same as?
Z-score.
That's my z-score, right? A standardized test statistic, a z-score of 2.25. So how am I going to use that to find my p-value?
Normal CDF.
Okay? There's something else I want to do on this curve first. I want to shade, right? Because I want to know, what is a p-value? Go back to this all the time. What is a p-value? It's the... So it's a probability of getting that statistic or more extreme, assuming the null hypothesis is true, right? So, should I go to the right or to the left?
To the right.
It literally, and it's not just, now be careful about this, right? It really depends on the alternative hypothesis, not where it's located, but the alternative is greater than. So it is to the right. Because if it had said less than, then there's no point in running a hypothesis test because our statistic wasn't even less than, right? But greater than, so how am I going to find that area? That's all it's asking, that probability. Think you were starting to say it earlier, Tyler? Were you the one who said it?
Use normal CDF.
Wouldn't I just use a normal CDF from 2.25 as my lower bound to 1,000 or whatever for my upper bound? So, does that make sense for that p-value? Bryson? Okay. So remember, I'm not making you do that calculation because the calculator will do it for us. However, that is what you are supposed to draw every time to explain the p-value. When you do the do portion of a hypothesis test, write out your formula with your values plugged in, draw out your normal curve, and shade that region. We just don't have to actually calculate that the test statistic and the p-value separately, but that's what we're calculating. I don't remember what that value is. So come on, pick up a calculator, we need practice with it, and only stats out, not the non-stat stuff, thank you. So practice, let's find that probability. I will point out, just logically, are there any of these that we can quickly eliminate? Look at those answer choices.
D and E.
D.
D and E are out. Even if I'm not sure what to do next, I got a 33% chance. Hopefully we know how to find that though. Let's actually type it in.
Was it 2.5?
Now notice how that asks for an area. You don't have the area, you want the area. So use your calculator to help remind you. Inverse normal, use the area to get the statistic. We have the statistic, we want the area, so that's normal CDF. Normal CDF. Must have accidentally hit 3. So number 2 is what I want. Yep. So what's my lower bound? So what was it? 2.25? Was that lower bound? Upper bound?
It's a lower bound.
Big number,
Well, what would we put as our upper bound?
big number.
Big number, right? 1,000, 10,000, I don't care. Technically, you could go to 5 and that's big enough, but
Really?
a big number, yeah. Because remember, Austin, how many standard deviations do we typically show? 3, right? So too much more beyond even just that's enough.
That's true.
Okay, but I just use that 1,000. So what do we get?
0.1.
122.
0.0122.
2.4.
There you go. Answer's done. B. That's a choice.
I do upper bound.
You're good. It's fine. All right. Questions about that? What are your questions? Yes, ma'am. Okay. Number 10. Let's look at it. Molly works for a meat producer. She needs to determine whether containers of ground beef have the correct fat content. She obtains a random sample of 120 containers, finds that 84% have the correct fat content. She then conducts a hypothesis test that P equals 0.8 versus not equal to 0.8. Calculates a test statistic of 1.1 with a p-value of 0.273. So which of the following best represents the meaning of the p-value? This is what we talked about yesterday. In general, when we say a p-value, what is that? We've said it also once today.
Probably getting that value more true.
Probability of getting that statistic, that point estimate, or more extreme, by random chance alone, assuming the null hypothesis is true. Guys, p-values assume the null hypothesis is true. So when I look at A, if the population proportion is 0.84, probability of observing a sample proportion of 0.8 is 0.273. Is that true?
No,
What's wrong with that?
because the population proportion is pretty
Right, remember like from the beginning, population proportion was 0.8, so A, it doesn't make sense. What was 0.84? That was the sample proportion. We want to pay attention to that. So if the population, well, B is out as well. Done. I only have to look at the rest. Notice C, if the population proportion is what?
0.8.
0.8. Do not forget, a p-value assumes what, Haley? What does the p-value always assume?
Null hypothesis is true.
The what?
That the null,
It does tell us about the population, but what?
that the null hypothesis.
That the null hypothesis about that population is true. Guys, the whole point of hypothesis tests, we assume the null hypothesis is true, and we build, and so here's the thing to remember out of that null hypothesis being true, that is how we build our sampling distribution, because the mean of p hat is p. the standard deviation of p hat, right, would be whatever that formula is, right? Square root of p times 1 minus p. The whole thing is assuming the null hypothesis is true. So we build that sampling distribution out of it. So the probability of getting that value or more extreme by random chance alone. So C, if the population proportion is 0.8, good. The probability of observing a sample proportion within 0.04 of 0.8. So what is that saying? So
Inside the deviation.
that's within, so 0. And I don't know if it's 1 standard deviation, right? But it's saying within. Is that what a p-value is calculating? The stuff in between? Because it's within 0.04. Okay? So that one's out. If the population proportion is 0.8, the probability of observing a sample proportion at least 0.04 greater than 0.8 is 0.273. What do you think about that statement?
Also no,
Why not?
because it's a two-tail that you're looking at, and the answer's on one tail.
Notice this language only has what?
One tail.
Greater than, one tail. But the hypothesis, or the alternative, was
No,
not equal to. Not greater than. Not greater than,
just not equal.
just not equal to. So notice it's at least 0.84 or at
Most.
most 0.76. There's my two tails. Not equal to. Greater than that value or less than the corresponding less than the mean. So the answer is, okay. So remember, I'm going through this somewhat quickly to talk it out. If you have a question, ask it, but also you have these on AP Classroom once you submit them to use to study, and then let me know if you want me to unsubmit it so you can do it again.
Can you unsubmit that last one?
Sure.
That I completely just closed my eyes and randomly guessed.
So Haley, right here in the hypothesis test for a single proportion, which of the following is assumed for the calculation of the p-value? Done. Right? We've got to assume that the null is true. That's how we build our sampling distribution. Alright, so here we got a p-value of 0.053. I'm kind of jumping a little bit, but we're asking convincing statistical evidence at the 0.05 level of significance. Do not forget, when is it statistically significant? When p is, because it is the probability of getting that extreme a value or more extreme by what again? Random chance alone. And if it's a low probability, then we don't think it's by random chance. We think our assumption was wrong. Sorry, yeah. Remember, we assume the null hypothesis to be true. So if we get a super low probability, we now believe that our assumption was incorrect, which is why what do we do to the null hypothesis? We reject the null hypothesis because there is convincing evidence for the alternative. Do I say the alternative is true? No. Do I accept the alternative? No. There was convincing evidence for the alternative. So was there convincing evidence here? No, right? Right away, we can say no. Also, notice here with A, what's another issue with A?
The values are backwards.
Not just that. There's a bigger issue to me with A. Talking about the sample proportion. What do we need to be looking at?
The population. Or everything. The whole.
If we're asking about convincing statistical evidence, we have to look at the p-value. Do not ever just base it on the sample and population proportions. It has to be based on the p-values, right, Austin? What? You always have to base it on the p-values. If you need to stand up, walk around a little bit,
Okay.
do it. Okay? C. What's the issue with C?
No p-value.
It's no p-value, right? What about D?
Doesn't really compare to
What's
the
the
p-value.
p-value?
There's no p-value.
It doesn't have a p-value. What about E?
It has to be.
It has a p-value, and notice it correctly compares p to
Alpha.
alpha. If p is greater than alpha, And I think someone's got hung up on this originally. Like, how different is 0.053 and 0.05?
Not much.
Not much, but is it greater?
Yes.
Yeah.
So it is not convincing statistical evidence. I'll say this, in the real world, we might go ahead and say that's convincing statistical evidence. On the AP exam, no. They want nice hard rules, so there's no wishy-washiness. It's a no. What are we gonna ask?
So, every time if the p-value is larger than the alpha, it's gonna be not enough to like.
Correct.
Because for some reason at first I swear it was the other way around. I don't know why.
I think you misheard and
really
miswrote it
misheard.
down.
And
Yeah.
then I just got fully onto them. That's why I was
Yeah.
so confused.
So here's one thing I want to point out. When I look here, I don't have to run the test. P-value 0.033. So my immediate assumption or thinking, now I started looking at the 0.01, right? Is it convincing statistical evidence at 0.01? No. When would it be convincing statistical evidence? If the alpha was what? 0.05 or 0.1. And so, would the null hypothesis be rejected at alpha of 0.01?
No.
There's not convincing statistical evidence at that level. Now I move down to C, D, and E. So I want you to look at C. There's an issue with it. What is the issue with the language on C?
It says there is convincing evidence, but there's not.
Yeah, if the null hypothesis is not rejected, it's not rejected because there is
No, no.
not enough evidence. There's not convincing evidence. Pay attention to your language. Fail to reject, not enough evidence. If you reject, there is enough evidence. Now we move into what alpha level? 0.05. At the 0.05 level, what should we do? It's got to be rejected. These both say rejected. And why is it rejected? There is or is not? There is convincing evidence. If P is less than alpha, reject your null because there is convincing evidence. Is the significance level of a hypothesis test equivalent to the probability that the null hypothesis is true?
No.
No. What is the significance level?
The alpha?
That's the alpha, which is the probability of,
Type 1 error.
huh?
Of a type 1 error.
Say it again.
Of a type 1 error.
Of a type 1 error. So which of these answers is that idea of a type 1 error?
A.
So I see A and C. So remember, we make a type 1 error when we reject the null, but the null was true, right? Reject the null, but the null was true. That's A. So make sure you study and you know those differences. That type 1, reject the null when the null is true. Type 2 is failing to reject when the null is false. So yeah, you can see, it's like that would actually be true, or this would be correct. If you fail to reject and the hypothesis is true, you did the right thing. Okay? All right. And sorry for quickness, but we gotta find a balance. All right, for C. Ooh, we ain't got time to do all those. So this one was all about the errors, I believe. So which of the following describes a type 2 error? Again, type 2, you
Fail to reject.
type 2 fail to reject when it is false. So when would you fail to reject? When there is or is not convincing evidence.
There's not.
And there is, you fail to reject when there is not enough evidence. Okay? So we can immediately eliminate D and E. We need to focus on A through C. So the null was the percent of defective parts is at least 2%. Ooh, I hate that language. That's wrong. What's wrong with that null hypothesis?
It's not equivalent.
It's not an equal statement.
Yeah, it needs to be. It is 2%. and the alternative is that there is less, right? So at type 2, there is not enough evidence that the percent is less than 2%. But what? The actual percent is, so there's not enough, but the actual is, what are you saying? Less than, right? There's not enough evidence. We failed to reject, but we should have what? Rejected, so the answer would be C. Right? We should have rejected if the actual percent is 1%. We should have rejected in that case. You're always trying to collect, yeah, you never prove the null. You collect evidence against the null by collecting evidence for the alternative. Right? Do you have enough evidence for the alternative? Okay. Which of the following indicates that the use of a two-sample z-interval for a difference in population proportions is appropriate? Do you need two populations of interest?
Yeah.
Yep. If you don't have two populations of interest, are you using a two-prop z-interval?
No.
No. Do the variables of interest need to be categorical?
No.
If you're dealing with proportions,
Yeah.
it has to be categorical, guys. Right? If it's numerical or quantitative, what are you going to be looking at? Not proportions, but means, which is what our next unit's on. Guys, remember, proportions, think about what we've done this whole time with proportions. We threw the globe around, right? We found out how many times our finger landed on blue. That's a category. We looked at Skittles, we looked at M&Ms, and we found out how many were correct, how many we guessed correct, right? Those are all categorical data. Proportions is all about categorical data. What about 3? The intent is to estimate a difference in sample proportions. Why do you say no for that?
Just for the population proportion of the samples.
Okay, that's one issue. I wasn't even thinking about that, but that's a good note, right? We never are trying to do, oh, it's a two-sample z-interval. So that's right. I was thinking we were doing a z-test, but yeah, interval. What do we always try to estimate?
The population.
Populations, right? We are all about the population. If we're making an inference, it's about what, Alyssa? The population, that's it. I must have had this backwards. 12 through 14 must be C. Okay. Random sample of 240, blah, 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 blah. Ah. So, we're looking at two different populations. I know it's kind of small, but does anyone see right away any of these standard errors that we can eliminate?
B and C.
Why B and C?
That's your margin of error with the critical value.
Ah. What does it ask? Does it ask for standard error?
I don't know. You just said standard error.
I did say standard error, didn't I? Yep, standard error. So be careful. Standard error, does it include the critical value?
No.
No, so B and C are out, right?
E is too, I think.
Yeah, what about D and D?
Also no.
Also no, what's the issue with D and D?
Well,
E doesn't have a critical value and E has the wrong critical value.
But we don't need the critical value, we only need the standard error, so be careful with the language, right? It did ask for standard error. There's a bigger issue with D and D, guys.
Because you have the combined.
It's
Is it, I didn't see the context of the problem.
Pretty sure it was two different proportions, wasn't it?
Yeah, it is.
Yeah.
Yeah, you want the difference in.
So we have a random sample of 240 adults over the age of 40, 234 adults age 40 and under. So we needed what? A two proportion. So I needed A, B, or C, but both B and C Yeah. had those critical values in there. So be careful and remember, when we include that critical value, that's not a standard error, that's a margin of error. Be careful with that language, that's why we use that formula here, right? Standard error is only this piece. It's talking about critical value, standard error is only that piece. Here, What are we checking right here?
10%. No, large count.
No, so that's not a 10%, that's just
Large count.
10, which is what?
Large count.
And so what is large counts?
It's both the successes and failures are 10 or more.
Normality.
Yeah, but look here, what are we checking for?
Independent.
Valid.
What does large counts check for? We gotta know this.
Independent.
Not independent, say it again. Remember, large counts is about normality. Independence is the 10% condition. Well, independence of selection. You just have to have two independent random samples, or populations. But guys, I need you to look right here. There is a key word where I don't have to do much work that tells me exactly which answer.
Sampling distribution. Are you looking for normal?
Not the only thing I'm looking for.
And difference.
No.
Sampling distribution.
Oh, there we go. All inferences are built out of what?
Sampling
Sampling distributions. All inferences are built out of what, Logan? Sampling distributions. Alyssa, all inferences are built out of what? Sampling distributions, right? So it's not that the population of deer within each region is approximately normal. That is true, but what we're focused on, what we care about, is the sampling distribution, right? And if both sampling distributions are approximately normal. Oh, and that's the other issue, right? With A, does the large counts tell us about the population being approximately normal?
No.
Large counts is only for a sampling distribution.
Cast on that one too.
All right, let's skip this one just for the sake of time. Part B.
Good, thank you.
210, 12, 13. Haley, you good over there, baby?
No.
All right, so Bryson, tell me this. There's a whole lot of information here, but I'm going to focus on the question. By the way, guys, whenever you have a long thing like this, right here, focus on the question first. Bryson, what is this question asking?
Which of the following is the best description of what is meant by 95% confidence?
What is that question asking? Is that asking about the interval itself?
No,
No, it's asking about the what?
best description of the 95% confidence.
Ish. Is there does anyone know a better language we could say there?
Context.
Not context, it does include context, what?
Confidence level.
Ah, confidence level, right? It's not about the interval, right? What do we mean by 95% confidence? That's my confidence level. What do we mean by confidence level? In repeated sampling, in the long term,
5% of.
so our intervals, right, will capture the parameter 95% of the time. And so we need context with it, and so pay attention. This is a great question for confidence level stuff. Go back and look at it. In repeated sampling with the same sample size, approximately 95% of the sample proportions from the younger group will be between those values. Is that accurate?
No,
Why not?
because it's about the interval, not the sample proportion.
So that's about the interval, right? The confidence level is about the intervals,
Yeah,
and it's also not about the sample proportions. It's about the interval capturing the
population proportion.
population proportion, the parameter, right? Confidence level is about capturing the parameter. B, in repeated sampling with the same sample size, approximate, because why do they keep saying same sample size? Why is that important?
Does it really change your anything?
Because the sampling distribution would have all, like the sample size would stay the same.
So in a sampling distribution, sample size stays the same. What happens if my sample size increases?
It would decrease variability.
It decreases that spread, that variability, right? If my sample size decreases, my spread
Increases.
okay. So that one's out. Oh, wait, yeah. We didn't actually finish reading it. Approximately 95% of the intervals constructed from the samples will capture the difference in sample proportions of people who would answer yes.
No,
Why?
because you're trying to capture the parameter. not the
Yeah, be careful. Break that language down. And I will say this, okay? Listen to me clearly on this. You could be easily very tempted to pick B, but make sure you read the rest of your answer choices. Because when I read C in repeated sampling with the same sample size, approximately 95% of the intervals constructed, man, it's literally the same exact language. will capture the difference in population proportions of people who would answer yes. You see how similar those two are?
Yeah.
That's when it needs to click to say, why the heck are those so similar? I thought it was B. What's the only difference?
Population.
Sample versus. That's how you break down an answer choice on an AP exam or on a standardized test. What's the difference? Sample versus population. And inferences are always about population. And those inferences are built out of sampling distributions. And don't forget, those we do not talk about probability because either we've captured or we have not captured. We do not talk about probability there. Oh yeah, oh my gosh, y'all, y'all killed me on this one. What's the answers that we should, I haven't even looked at the question. But what answers should I never have picked for this problem?
Deary.
Deary. Hypotheses are always statements of equality. Or the null hypothesis, I should say. And then when I go back up, students who wear, what are we asking?
School colors to the effect of.
Yeah, but students at the high school want to investigate whether they have more school spirit than students at Blake High School. So right away, which answer do we want for alternative? Greater, right? More school spirit. Make sure it's in the right order, but it is Hereford versus Blake.
Yes.
So if they have more school spirit, Hereford minus Blake would be greater than 0.
Can I go to the restroom?
Nope, never allowed to use restroom for the rest of your life. Yes, you can go. Sorry, I'll quit doing terrible jokes. Alrighty then. Actually, I won't. Like, let's be real. I'm not going to quit doing terrible jokes.
At least you acknowledge they're terrible.
Yeah. So have the conditions for statistical inference been met? So 2 schools are, so what are the conditions for statistical inferences, specifically with 2 sample like this?
Random independent.
We need random and independent samples, right? What else? Large counts and 10%, right? You gotta check those things. Do we have less than 10% of the population?
Yeah.
Yeah, it's 2,000 students, right? Just glancing at it, does it look like we would have large counts?
Yeah.
Yeah.
No, you don't have for the probability of failure. For
I was saying, you have 98 out of 100,
and 142 out of 150.
and you have 142 out of 150. And I will say this is close, because remember, it would be N1 times the combined sample proportion. Remember, there's a hypothesis test, so I need the combined sample proportion. And that would be perfectly fine, right? Ooh, this might actually work. Let's see. So the sample size of 100 times the combined, that'd be 98 plus 142. So 240 out of 250 would equal something.
0.96.
0, no, what? 100 times 240 out of 250?
Oh, no.
So it's got to be a pretty big number, doesn't it?
Should be 96.
96, okay. And then if oh yeah, so it will not. Because if that's 96,
The other's gotta be
what would be the failures?
4.
4, right? And they both got to be greater than or equal to what, Josh? For large counts?
10.
It's got to be greater than or equal to 10. You focus? You with me?
I'm trying. I don't do good.
Okay, I'll hold on my pants.
How are you with studying on your own? Are you at least good there?
I don't do a lot of studying on my own.
Oh, don't tell me stuff like this.
And the hot one,
I mostly study during schools.
Gotcha. You're going to want to step up that studying for college, I will say that. Alright, so we are looking here at a difference in proportion of starfish. Anyone see any answers that can immediately be eliminated for a difference in proportion of starfish?
A and B. Single ones.
The single ones, A and B, right? Those are out. Also, it's not going to be counts here. We need proportions.
Yeah.
Now glancing down here, I need to go back and look. Because now I'm looking at the
E
differences.
looks wrong.
Yeah, it can't be.
E looks.
Oh yeah, it can't be E, that's not the square root of everything. And then what would I need to do to find, I'm not going to go through all of it, but what would I need to do to find this proportion for this hypothesis test?
It'd be combined, right?
Right, do not forget, we have to get the combined sample proportion when we're doing that hypothesis test. Because we have assumed that those two proportions are what? Equal, right? We've assumed that they are equal. Alright. That's a whole lot of multiple choice. We gotta do some free response. No, we finished, we almost finished it. Y'all ask questions about this. Go quickly. So this is that free response we did for homework last night. We answered most of those questions. So one thing I do want to tell you, listen to me clearly on this. As far as I've been able to tell, the free response very rarely has the two sample stuff. Very rarely. At least with proportions. We still want to make sure we study it, but it's mostly going to be on multiple choice. Here though, what does it ask us to do on the 2022 free response question? Cool. What? Construct a confidence interval. Alyssa, what are the 4 things we need to do every time it asks us to construct a confidence interval?
3. Tell me if I'm right with the first one, and then I will.
Which one do you think?
State.
State!
Okay. Plan, do, conclude.
Okay, state, plan, do, and conclude. So, state. What did y'all state here for this confidence interval? Yeah, state what we're doing. What are we doing?
Making confidence, I think.
Okay, so is it just, do we just say confidence interval?
95% confidence interval.
So, so we're estimating what? I need context. Estimating.
Proportion of all teenagers in the U.S. would respond.
All teenagers. And so notice, like, I'm not doing anything fancy other than just rewriting what they have. U.S. who would respond.
That they use video streaming service.
Make sure you actually write it down, right? There's something else I want to say with this, though. So write the rest of that context down.
With 95% confidence.
Right? So at the 95% confidence level. If I'm doing a confidence interval, right, Deacon? If I'm doing a confidence interval, I got to make sure that I give context, what I'm doing, and at what level.
Do I have to say confidence level, or can I just say with 95% confidence?
You could probably say with 95% confidence. I don't want to say 100% that you can say that, but I'm pretty sure you can. That's a question I'll have to ask at some point. All right. Peyton, you got these free response questions out? So, I would have these free response questions out so you can check yourself, or at least write these down. We didn't do them because we were apparently doing other stuff.
Yeah, this project.
Yeah. But the project's not due till Monday.
Yeah, but
But you need like the day to day, I know. All right.
on Friday and Saturday I'll be out of commission, so.
Why are you saying you're out of commission?
We have to look at
Let's, I don't need to know that. I don't want to know that.
Do not
Let's-
disturb.
All right, plan. What needs to go into our plan here, guys?
the general formula,
Or,
I'm gonna do what general formula? For what? A
confidence.
confidence interval. So what's my formula for this confidence interval? And what's my statistic gonna be?
P hat.
P hat plus or minus
V square.
my z-score. So critical value times
Standard error.
standard error, which is, and so remember, you can just pull, right? So statistic, critical value, and standard error. You can write that down off the formula sheet and plug it in. So what am I going to put for my standard error?
P hat, times 1 minus P hat. So it's gonna be, or.
Okay. And so you don't have to write that formula down, but I definitely recommend it because that formula is going to help you remember your conditions. Bryson, what's the condition for this statistic? Okay, let me ask this, do you remember any of the conditions that we need to meet?
Like, so we gotta be balanced.
So we can do a confidence interval.
This like a little bit
Okay. Okay, so we need to check normality. Hey guys, which part of this would be the normality component? I mean, that's how we check it, but when I look at this formula, where is that normality necessary? The critical value, right? Like to be able to use that z-score and that 95% confidence level, that needs to be normal. Okay, cool. What other things, and so approximate normality, right? Randomization, what part is the randomization important for? If I don't have random, is that p-hat going to be any good? No, my data's crap if it's not a random sample. So random. And here then is my 10%. So let's think through it logically. Do we have random sampling? Says so, right? Random sample, bet, check. 2022, number 4. Approximate normality. Someone brought it up. What do we check for approximate normality? Large counts. What is that?
N times P1 is greater than for P hat.
I would say I don't even need P1. It'd be P hat here. What is N times P hat here? How would I find it?
Greater than 10.
How would I find what N times P hat is?
920 times 59%.
Okay, come on. Somebody, 920 times 0.59. Help me out here.
542.8,
How much?
543.
543. You tell me, is that greater than or equal to 10?
Yeah, it's a little over, yeah.
It's a little bit.
And so remember, these are going to be complements. So if that's 543, I don't know, 920 minus 543, whatever that is.
So
Hey, do you have your free response?
a couple over
It's
10.
actually sitting in my car, because I cleaned out my car.
Why don't you ask for a copy?
Because it's already happened, so it's just don't have that.
Okay, but do you have it to write stuff on right now? Or could I print it out for you really quickly? Does anybody else not have their stuff with them so I can print it out for you real quick? Take that as a no. Okay, you can go grab it off the printer in the back. Okay. So, what is this complement going to be?
Compliment,
It's gonna be
377.
Thank you. Is that greater than or equal to 10?
Yes.
Check. Do we have less than 10% of all teenagers in the U.S.?
Yeah.
That's a safe assumption. That's not just an assumption. That is a fact. There are more than 9,200 teenagers in the U.S.
Is there that?
Yes. Pretty sure there's more than that just in Tuscaloosa City.
Is there that?
Yes. All right, do. What do I need for do?
Fill in your numbers for the general.
I need to fill in my values for the confidence interval. So what's p hat?
0.59.
0.59. Plus or minus, what's my critical value?
1.96.
If it's that 95%, which it usually is, 1.96 times square root of,
Yeah.
which is
0.59. 0.49.
or 1
41.
divided by
920.
920. Am I going to have to type all that into my calculator? Like, type this formula out?
Nope.
No, pick up that calculator, make sure you run your confidence interval. It would have been helpful if we had practiced this last night for some of us.
Well, I did the wrong.
Not you. Well, I assigned that one too. I'm talking about the ones who didn't even try last night.
trying to do count.
My bad.
I had a paper
I
route.
didn't even have homework in town.
I was trying to figure out how to do anything.
Hold up. Why?
I don't know. I forgot how to do it, so I just fill it in myself.
My guy.
Wait, huh?
It's the simplest thing. What's the button lets me do cool crap? Menu. What are we studying? Okay, what are we trying to do?
Stat test 20.
If we're doing a confidence interval, I believe, right? What type of confidence interval would this be?
What type?
Or no, it'd be
Do you-
proportional, right?
Do you have two proportions?
That would be one.
Okay, we have it. There you go.
There we go.
Just walk it through, right? Guys, one proportion Z interval. That's what we're looking at. What are you going to put for your number of successes?
Don't we need?
Remember, those are my successes.
Oh,
That's one of the reasons why we check our conditions.
Don't we need what type it is on one of those, the set or plan?
So this tells that it's a one prop Z interval.
Oh, okay.
By writing out that formula, so you can say one prop Z interval, but also that formula.
Okay.
So guys, Lexi asked a good question, and I believe they say this in the book, that you need to name the procedure, name the formula, but if you write out the formula, you've already done that. Yes,
What number of successes just be,
the 543, right?
yeah, divide out 3.
That is my number of successes, not the proportion of successes, the number, okay? So what's my confidence interval for those who have gotten it?
My calculator's trying to fight me.
0.5584 to 0.6220.
Let's chop it.
And so the conclude for our confidence interval, with what confidence?
95%
So
confidence.
with 95% confidence, and I like to just use the language from the book, the interval of 0.5584 to 0.6220 does what? What does that interval do, Bryson?
Captures the true proportion.
Captures the true proportion, and what do we need to have after that? Okay, I'm going to stop there because time, but true proportion and context. True proportion and context. Make sure you don't put quotation marks context. Make sure you put context, just to clarify. Just depends on your level of comfort with it, yeah. Okay, I'm not gonna, now on the back side of this, there's a B. It says, based on that confidence interval in part A, do the sample data provide convincing statistical evidence that the proportion of all teenagers in the US who would respond, notice that language, it doesn't say who responded, but who would respond, right, because it's all of them, that they use a video streaming service every day is not 0.5.
Yes,
Why is that a yes?
because 0.5 isn't captured by the interval.
Yeah, 0.5, and so remember that interval is an interval of what type of values? It starts with a P. Plausible values, right? Is 0.5 even one of my plausible values? No, so it is not, there is convincing statistical evidence, right? There's convincing statistical evidence that the proportion of all teenagers who would respond, they use a video streaming service, is not 0.5 because that is not a plausible value from the interval. There is convincing statistical evidence because that is not a plausible value from the interval. So there's convincing statistical evidence because 0.5 is not a plausible value from the interval. I know, it's really tough. Or is that just like calculus residual? That. Do you complain in her class about my class the way you complain about hers?
No,
and mine?
I tell her to her face, this class is easy.
Be nice. No teacher wants to hear that.
I think calculus teachers know that the class is rough.
Oh, this one.
It's tough. It's tough. It's good though. I love calculus. I would love to get a chance to teach calculus one
Of course
day.
you did.
Yeah, I'm a giant nerd. I love learning all this
Yeah.
stuff. All right. Right away, I want us to look at this. We're not going to have time to go all the way through this, but with number 4 here, what is the key detail that tells me right away what to do?
Run a p-value.
I think it'd be a great idea for you to answer my question.
Get a p-value.
Not just get a p-value, like there's something else, like, because a p-value is not the only thing I need here. What do I need? I need convincing statistical evidence. That's the language, so what do I need to do? I need to do a hypothesis test, so what are the 4 things I need to do then?
State, plan.
State, plan, do, and conclude that does not change. There is a little bit more in the state portion than you had. In the state portion, what do I need?
Null hypothesis.
I need a null hypothesis, and then, so my null, to investigate the belief of what? They believe that if past customers are offered $10, more than 40% will place an order. So null, the proportion is 0.4. The alternative, greater than 0.4. Do not forget, you cannot stop here. What do you need to do with that P? Define P. So I don't have time, I'm skipping that. But I need to write my alpha. What's my alpha?
0.5. Or 0.05.
0.05. Okay, so null hypotheses, define your P, define your alpha, that's stating things.
They already defined alpha, we have to define it.
Still rewrite it. Take that 2 seconds to write alpha equals 0.05. Okay? Plan. I would write out what I'm doing. We've already said it's a what? Are we doing interval test? Hypothesis test? What type of test? One sample test for proportions. You can also just say a one prop Z test. Either way, I don't care. Make sure you call it what it is though. What are the 3 things I need to check?
Random.
Does it state random?
Yes.
So random. And it might be better to say this, stated, something like that. What else do I need? Large counts. And so now be careful here. Am I going to use n times p hat this time?
No.
We have an assumed p, right? So we're not doing n, we're not using p hat if we have an assumed p. So n times p, right, which is a sample size of 90 times that 0.4. I think that's right. That's greater than or equal to 10. So 54. And then 10%. Do we actually have enough here to assume 10%?
Yeah.
It does say a large company, right?
Yeah.
Sells supplies online, so it's safe to assume 90 is less than 10%.
You would assume they had more than that. More than 900 people.
Apple. I don't know.
You got too many questions.
Under our do section, do your Z, draw your normal curve, and tell what that p-value is. Now, I'm going to get all that, I'm going to write out my formula. Whoa. 38 out of 90?
Yeah.
So 38 out of 90 minus 0.4 divided by square root of 0.4. But I'm going to put that into the calculator. Please run your hypothesis test quickly. I'm going to pass out our set of notes for the next little bit. Do not have fair models yet, but I will have them tomorrow. When you start studying for that AP exam, you're going to be so thankful I made you do these fair models.
Mr. Kane, let's be real.
Thankful now.
I will not be looking at them.
Well, then you're studying the hardest way possible.
What's the hardest way possible?
Not using your fair models. The things that are designed to help you learn or review, because it covers everything instead of, using a several 100-page book, maybe like 700 or 800 pages. Huh?
They are.
I know. All right. Everybody get a copy of the notes? I don't know why I have so many left over. Thank you. Makes way more sense. All right. So what was Z equal to, by the way?
0.4303.
0.4303?
Yeah.
Was that Z or P?
That's Z.
Okay, so Z is 0.4303. So my p-value is probably going to be pretty high.
Yeah, 0.33.
Yeah.
So, so what was the p-value equal to? 0.33?
Yeah.
Okay, so I'm not going to go through the whole thing, but there's 4 things in the conclusion. Actually, might as well do this quickly. We're already here. Based on that p-value, are we going to reject or fail to reject? We fail to reject because, and please use actual language, I'm being quick. Fail to reject because what?
Not significant.
So the p-value, how do we know that? Because the p-value of 0.33 is greater than alpha equal to. That takes care of 2 things I got to write. What's the other thing? We fail to reject, I should say null hypothesis, because of that p-value. So there is not, remember it's now about the alternative. There is not convincing or statistical evidence for the alternative, and then context. It doesn't really matter where you put the context, but what do you always have to have?
Context.
Context, because is anything we do these like random numbers in space? No, there's context. Now, please pay attention to this right here. Based on your conclusion from part A, which of the 2 errors could have been made?
Type 2.
We failed to reject, but it could have been that the alternative was true. That would be a type 2 error. Notice, because we failed to reject, it could have been a type 2 error, and interpret the consequence of the error in context. So make sure you read that, pay attention to what you just did, but there's that. Write down what you need to, be ready to ask questions, and make sure every group has a laptop. Yep. Hopefully they're open, but everyone has at least one that works.
No. No.
So someone log into the laptop for your group.
This one's dead, Mr. Kenny.
Might want to grab the ones that are charged.
Yeah, there was some of them that are still charged. Come grab a different one then.
Yeah, it's one of them.
Although if you have, hey, if you have an iPad with you that's already charged, you can use that, so you don't have to worry about logging in, because as we know, these things are pains in the butt. Do one of you have your iPad?
4%.
That's a 13.
Okay, one of you go grab, I guess, one of the Macs that's not dead. These are all dead. Did you grab one of those? Good. Lexi, you have one?
Yes, sir.
You have one? Alright.
Where are we going with?
Nothing yet.
Oh, okay.
About to get there. Okay.
Mine's charged.
Alright, I forgot about this. One last thing. Right here. No, is that what I wanted?
How many found in the United States? Yes.
Oh, that's one of the few times they ever made a 2 proxy test, so there is that.
Are you reading it? Oh, we don't have that. I don't have that. Do I have that?
Just you take life.
No, don't worry about it.
You begin.
That's not what I thought it was. Okay, so here's the beginning of the notes for the next unit. The next unit is chapter 10. I have not loaded to Schoology yet. I'll do that today. I'll load chapter 10 and 11 at the same time because we're doing them. Now, here's a little difference this time around. A farmer wants to estimate the mean weight of all tomatoes grown in his farm. To do so, he will select a random sample of 4 tomatoes, calculate the mean weight, and use the sample mean to create a 99% confidence interval for the population mean mu. Suppose that the weights of all tomatoes on his farm are approximately normally distributed with a mean of 100 grams and a standard deviation of 20 grams. So, What's weird about this? Or what's different about this, I should say? We're doing means instead of proportions. But what do you think we're going to do?
Use means.
Basically the same thing.
Say that again.
Basically the same thing.
Basically the same thing. So we're trying to do a confidence interval, so we're going to have to start with a what?
Yeah.
One proxy test. Or that would be wrong.
I'm guessing we'll use 2 samples, the interval.
Well, pause and back up. Pause and back up, and I want us to think about this. I'm asking, where do we start?
With a formula.
Oh, okay.
Even before the formula, say it again, Alyssa. Don't we need to start with a state?
Oh, yeah.
Oh, okay, right. We got to start with a state, okay? We got to start with a state. And so we would be trying to create a confidence interval to estimate mu, the true mean weight of tomatoes, because we love tomatoes, right, Deacon?
I hate tomatoes.
I forgot, you're the one that hated them. All right, with what confidence level?
99.
99%.
100%.
And then from there, I do want to point out, someone said the formula. What do we think this formula might be?
One sample is equal to the interval.
Yeah.
Well, that might be what the calculator is. I asked, what do you think the formula might be?
Good question.
Statistic plus or minus critical value.
Thank you.
Times standard error.
Stat plus or minus the critical value
Times standard error times statistic.
times standard error. Okay, so what do you think it would be for these means? What's my statistic going to be?
Mean.
X bar.
Thank you. It's got to be not just mean, it's got to be the sample mean.
Wait, isn't mu population? What's the-
Correct. But that's the parameter, that's what we're trying to estimate,
Okay.
right? Plus or minus what? Some z-score, right? Times what?
Standard error means.
Yeah, what do you think the standard error of means is? Have we studied that? Can we find it somewhere?
Yeah.
Oh yeah, let's look at that formula sheet. When we don't know, maybe check out that formula sheet. Might be our best friend.
That's a much simpler equation.
Yeah, what is the standard error of our sample means?
S over the square root of. Wait.
So sample standard deviation divided by the square root of n. Or remember, there is also the true standard deviation of my sample means, which is just sigma divided by the square root of n. We saw that with our what again? Because what are all inference procedures built out of? Sampling distributions. You remember that standard deviation from our sampling distribution? Yes, Mr. King. Great. I'm so glad we remember that. So here's what I need you to do. I need you to go to rossmanchance.com/applets. I need you to follow those directions that's on the notes. We need to do this quickly. We've got about 13 minutes where I need you to find out some key ideas.
Wait, so what's S? in that?
Follow 1 through 4, sample standard deviation.
So how do you figure that out?
Well, so if you look back at the problem, now we'll point this out, guys. So it says, suppose that the weights of all tomatoes on his farm is normally distributed with a mean of what? 100 and a standard deviation of 20. So would this 100 be my mu or my x bar?
X bar.
That's
Mu.
All tomatoes.
is that 20 s or sigma?
Sigma.
That's gonna be sigma.
That's population, right? So pay attention to that language. But follow those directions of 1 through 4, and we're going to talk about it. And if you want to shout bingo to your heart's content, do it. But work with each other in your small groups to complete 1 through 4.
Mr. Graham, I'm still confused.
We're
on that.
What do you-
simulating confidence
Are you finding
intervals.
this?
That's sigma.
Dude, hold on. We're not finding the s, it's given. But also, you know how to find s from a... If I give you data...
Yep.
Are you talking about for that... Hey,
That's not S.
yeah, that little s. Standard deviation.
Oh, so
That we've been
I
studying
never
since the beginning.
changed.
It's the same. No, it has not changed.
What?
The sampling distribution for
I'm not G.
the sampling distributions changed a little bit, but I need you to follow those directions. Okay, Logan, move around so you can work with Bryson or see with Bryson. I need you working together to complete it. Talk to Deacon first, and then I'll come.
Okay.
Yeah,
Gotta do something.
What's the problem?
This is choose
I mean, I've got it pulled up here. Is it all filled out already?
Simulating.
I'll get this next week.
Simulating
Okay.
Did you launch the simulating confidence intervals for
Celebrate.
population parameter?
Yeah, that's what we did.
Is that
Mr.
just whole
Kenny, can you come
website?
here?
Well, I mean, that's just the title of the whole thing.
Oh, yeah, it looks right.
Is this, ours is displaying a high.
Wait, is there a is there one of those?
Did you change it, the statistic to mean?
Oh, big box for it.
Oh, okay.
Look, read. Choose means from the drop-down menu. Leave the other menus as normal. Zero sigma, mu, sigma, 4.
For the drop down.
You're so mean down.
This is
Okay.
right?
As normal and
I think this is right.
choose me.
Alright.
Where's the?
This is 20.
How well did the mean length of work compare?
It's here. Oh,
Which is the confidence.
To be.
yep, figured it out. So U is 100, sig is 20.
Is this okay?
Okay, so keep going. Yell out bingo if you get an interval that does not capture the mean. So call out bingo if you get an interval that does not capture the mean.
How do I
You
make
did
it?
it. Keep going.
Sample.
I have no.
What's up?
Oh, you've already done a few thousand? That's cool.
Oh, we have? Oh.
30. Oh, no, you've done a.
Oh, bingo.
You can even change this up at least like 1,000. And just run.
I mean, you can run a simulation, you shouldn't be
You gotta go down.
Goes down on these.
Alright.
So now it's P0.
Okay, and how do we get?
Bingo. And what are we doing? Alright.
Keep it going, right?
Okay.
Now you're doing ones at a time, right? Let's make this a little bit bigger. Because remember, confidence intervals are in the long run, right?
Every time.
It's just some like.
Okay. I know. Did you do 10,000? Hot dang. Look at it. Look how many missed, right? Okay. So I'm gonna do what Lexi did right here. So Lexi decided to do not just 1,000. She did 10,000 at once. There's a whole lot going on here, right? But you see these reds that are off to the right? So what are these reds representing? Intervals that are not capturing the parameter. Any guess how many of those, or what percent of those intervals are missing the parameter?
99.
Missing.
5%. 5%.
What confidence level did we use? 99% confidence level, right? So what percent are missing probably? 1%. What percent should be capturing? 99%? What does that say? 98.9%? That's pretty darn close, isn't it? What does y'all say? 98.9, 99, 99.1? Is that working pretty well?
Well, it's like a Christmas tassel. It does.
Okay, look, hey,
Hey, Mr. Kenny, we did a 1 million.
that's impressive. Okay, but let's look here. What the real question is, listen, focus on your capture rate. What was your capture rate? What percent captured the parameter? About 99%. So, number 4, here's the key. How well did method 1 work? Right? How well did method 1 work? Did it have the right capture rate?
Yeah.
So, doing a z-score with sigma has the right capture rate.
I don't know how to spell anymore.
I need y'all focused on this. This is the key to everything that is different about means from proportions. I need you to pay attention to this. This capture rate was correct, right? Z with sigma. Now, I need you to watch this. One other thing I want you to see is, I'm going to run a couple of intervals again. Do you think that those intervals are about the same width or different widths?
About the same.
About the same, because we're using sigma divided by the square root of n. That doesn't change, right? Those have the same width every single time. But let me ask you this, because this is an important question. How often do we know what sigma is, but we don't know what mu is?
Very rarely.
Very rarely. It's going to be very rare that I know my population standard deviation and I don't know the population mean. That doesn't make sense, does it?
No.
So instead of using sigma, right? So go to the method here. Instead of z with sigma, do z with, what are we using to estimate sigma?
S.
S, right? So do z with s. Check your capture rate now. It's a little different.
It's like no.
Oh, did you already do that? You already did that.
I want you to notice, does it still capture at the correct rate?
No.
No, what rate is it capturing at now?
Around
About
90.
Around 90, 91, 92%?
Yeah.
What rate was it supposed to capture at, Peyton?
Sorry, ours isn't better.
No, but what was the rate supposed to be?
99.
99%. I want you to look closer, maybe do a few less intervals. Are the intervals the same width now?
I'd say 89.
Okay, but the point is does it have the right capture rate? It definitely does not. But again, I want you to look here. Look at your intervals. Are they the same width now?
No.
Because the S changes, right? So, what are we finding out? Does Z with S have the right capture rate?
No. But why?
Because I just actually showed it. Hold on 1 second. So right here, why, right here guys, why does Z with S not have the correct capture rate?
Percentage changes.
What changes? Before, remember, did the width of my interval ever change with
No.
sigma?
No,
No, but with S, what changes?
the width.
The width of the interval. Because the width of the interval is changing with S, right? Because S is different for every sample, right? The interval width changes. And so my capture rate is to what? To low. It's supposed to be 99%. We're now getting 90 or 91%. So what are we going to do? Well, the answer is I cannot use Z. What do we have to use instead if we have S?
T.
So remember I mentioned this a few times. If you go back to your method and you pick T, okay? T is the test statistic for means, okay? So, let me... I just want to show this really quickly, right? So method 2, we just did this. Number 3, right? If we look under method 2, using S instead of sigma, did we have the correct capture rate? No. Notice it even asked, I didn't even realize it asked this question, but I'm glad it does, I forgot about it. What do you notice about the length of the intervals that missed? Typically, when the intervals missed, the length was smaller. So what do I need to do to those intervals to capture better? Make them larger. Our T distribution has more spread than our Z distribution does. And so that's what's going to happen here. So if you look at method 3, and we use T instead, right? So I'm going to reset. I'm going to use T instead. What is my capture rate now?
Capture rate,
It's 100% right now. What do you think it'll be long term though?
99.
So notice I'm at 99.3, 99.2, 99.2, 91, 99.1. So when I use means, right? And so last wrap up detail, when I use means with S to estimate sigma, we do not use Z. What do we use?
T.
Use T. We're going to talk more about what that T is tomorrow after the test. But do not use Z with your means and with S. So what do we not use with our means and S, Peyton? Z. Logan, what do we use with our means and with S? T. Okay? So, by the way, Bryson and everyone else, you were like, hey, so are we going to use one sample Z test? The answer is no. We're going to use one sample T test and one sample T interval. Yes, sir.